Welcome back to our Unity Gaming Services tutorial series. Now that we have an authenticated player from video number 2, we can start creating, modifying, and saving player data. When a commercial game goes live, it's an open target to cheaters and hackers who can ruin the experience for everyone. Any client-side code built from your Unity project is vulnerable to reverse engineering and manipulation. For this reason, we're using Cloud Code from the start. Cloud Code is a service for writing and running server-side code in the cloud. Think of it like an inaccessible fortress in another dimension where logic and data can't be reverse engineered or manipulated. We'll start by setting up Cloud Code, and then we'll implement player username input with Serverside Validation, which will check that the name is the appropriate character length. We'll then integrate Unity's Cloud Save service by using SaveData and GetData method examples from the documentation. After setup, this video is all about getting comfortable with client-server communication. This is different from typical self-contained Unity projects in that it's more like a conversation between two different systems. In the next video, we'll build a system for handling new and returning players. Finally, in this video, we'll implement Unity Analytics since it's really easy to get started with getting real-time insights on your players. In the series so far, we've been working in a light example project. So let's continue with that and set Cloud Code up. Our first Cloud Code setup step is to go to the package manager in the Unity registry and install the Cloud Code package. It's also a good idea to download the examples. Switch over to the Project Settings window and we'll now see Cloud Code under Services with the other services we've enabled. If you click on Go to Dashboard from here, you'll get taken right to the About, Setup Guide, and documentation for Cloud Code. Back in Unity, in the Package Manager, we'll also need the deployment package from the Unity registry. It appears we have to update that, so let's do that now. Next, we need to download and set up .NET. Go to .NET.microsoft.com, click Download, and click Download .NET 9. Go ahead and install .NET. I've already done it. Then go to the Unity editor and open the Preferences window, and then select Cloud Code. On Windows, that's Edit Preferences, and macOS, that's Unity and Settings, and then Cloud Code. In the .NET Development Environment section, modify your .NET path to the one you have installed. Mine is in Program Files /net/.net.exe. Click Apply if you needed to make a change. And next we need to set up the deployment window. Go to Services at the top and select Deployment. And I'll dock that here for now. Click on Deployment Settings. Then choose one of the environments. We just have one, production. Now let's create a C# module reference file. Go to the project window. Let's just create this in our asset folder for now. Right-click to create, Services, and then select Cloud Code C# module reference. I'll name mine UGS Tutorial Cloud. Whatever your project name is, I suggest to just add cloud to the end because it'll make things a lot clearer going forward. Select the Cloud Code module reference file, and then take a look in the inspector where we can see a couple options. We want to click Generate Solution, which will create our Cloud Code C# module solution. Note that this solution will be generated in a folder named the same as your reference. So if you're following me, it'll be your project name, Cloud. We can also see the Cloud Code reference file in our deployment window right here. All right, go ahead and click Generate Solution. Then we get a message that the solution generated successfully, and we get a log on that too. Let's take a look at our project folder. And that's outside of Assets, by the way. There's the UGS Tutorial Cloud folder, and inside it is the UGS Tutorial Cloud solution, just like we see in the inspector. I'll right-click the solution and open it in Visual Studio. If you don't see your Solution Explorer, go to View, Solution Explorer, and then open up example.cs. If you see a warning about the project is targeting a version of .NET which is not installed, click Install and you'll be prompted to download .NET 6, which I'm guessing the little example was created in. In this class, we have a Cloud Code function that is called say hello. This function just takes in a string and returns hello string. Keep this open, go back to Unity to Deployment, select your module, and then click Deploy Selected. And then we have a status indication that the module is up to date. Now that we've done this, let's go to the Unity dashboard, click on Cloud Code, and then in C# modules, you'll see your module uploaded. Click on the module, and we'll see the sayHello method endpoint. It takes one parameter and returns a string. Now, how do we actually call this method? Go back to Unity, and it's actually very easy. The first thing we need to do is generate bindings, and you'll need to do this anytime you have new Cloud Code functions or significant changes. Click on Generate Bindings. Bindings are type-safe client code. And now we see our bindings have generated in a Cloud Code folder. So let's check that out. What generated here is a wrapper for our function calls. So now we want to call this code from our game. Let's for now make a new script, and for now I'll create it in the player login folder. Let's call the new script Player Data Manager. Start with adding the Unity Services Cloud Code generated bindings and Unity Services Cloud Code at the top. Then we need to initialize Unity Services, but we're already doing that in our Login Manager script in Awake. And we only want to initialize the services once in our project. It makes the most sense right now to do it in the Login Manager before we try signing in anonymously for a returning player, which of course uses the Unity services. Eventually, we want to wait to call Cloud Code until the player has successfully signed in, because there's many things we want to do in Cloud Code that will require the player to be authenticated in one way or another. In the Login Manager here, let's make an event for when the player has successfully signed in. And then let's invoke this event after sign in anonymously async. So right now, for simplicity, we're handling this for guest play and for returning player, but in the future, we should also invoke this event or have it in some kind of handle successful sign-in method in each of our sign-in methods for Unity sign-in, Facebook sign-in, etc. Go back to the Player Data Manager. Note that your bindings will be called the default at this point, My Module Bindings. We'll also need a reference to the Login Manager to subscribe to the Player Signed In event. And let's subscribe a method called InitializePlayer to the Player Signed In event we created. Next, let's initialize and cache our Cloud Code bindings by creating a new My Module Bindings instance. Then in InitializePlayer, we can use the bindings to call the sayHello method. We can call any Cloud Code function from the bindings. And finally, before we try this, let's unsubscribe from the Player Signed In event on Disable. Back in Unity, create an empty game object and call it Player Data Manager, and add the script to it. Then drag in the Login Manager and put a name in the name field, and press play. If you don't have a player ID showing up, press the anonymous login, and then you should see the hello, your name print in the console. Stop the game and go back to the example script in the cloud solution. Let's say the player can edit their username and we want to validate and save this in the cloud. Write a new method called handleNewPlayerNameEntry, have it take in a string and return a string, just like the example. As with the above, let's add a Cloud Code function attribute to our method so the function can be called remotely from the client. We'll get to saving the player's name next, but let's first check that the player's name is valid. We can do a couple common validation checks here, like checking whether the name is less than 4 or greater than 16 characters, so that would be invalid. And we can also use link to check whether there are any special characters, that is, all the characters should be a letter or digit. If the name is not valid, we can throw an argument exception. This then is our server-side validation, and we'll come back to the validation topic in a moment. Open up Player Data Manager in our Unity project and create a new method called SaveNewPlayerName. Let's do a try-catch block to handle any errors and a debug log for the player name. Now, if we try and do await my module bindings, we see the sayHello, but we don't yet see the handleNewPlayerName endpoint for the Cloud Code function. That's because we need to generate bindings again. So comment this code out so there isn't any error. And you can either keep project settings open and in Services Cloud Code generate all modules bindings, or you can go up to Services and generate bindings that way. Now, it's likely you'll get an error here because that example script is in new projects and in the sample we downloaded with its own Cloud Code module reference. When we generate bindings, both are generated, so we have duplicate MyModule bindings, so we get these errors. The easiest fix is to just delete the sample folders. That'll be in Assets Cloud Code. Delete the bindings that were generated. And then generate the bindings again, and everything should be fine. Now we just have the Cloud Code reference for our project. Generate bindings, and the errors are gone. After that completes, go back to the script, uncomment or retype the name of your bindings, UGS tutorial bindings for me, and there you should see the handle new player name endpoint. Now we've done server-side validation in Cloud Code, but we can save on server calls and provide more immediate feedback to the player by doing client-side validation too. Go to the cloud solution and copy the isPlayerNameValid method, and let's implement it on the client side in Player Data Manager. That way we can immediately give the player a pop-up that the name is too short, long, or otherwise invalid. Back in the editor, create a button for Save Player Name. I'm going to create mine in a new canvas. And assuming that you are signed up with an anonymous account in the editor, you can deactivate the sign-in buttons if you like. And then drop the Player Data Manager into the onClick slot, and let's have onClick trigger the Save New Player Name method. Select the Player Data Manager because for simplicity, we'll just type player names on the component in the inspector to test. We have one more important step. We generated the bindings, but we needed to deploy the module to the Cloud Code service to make the endpoints accessible to the game client. I have the deployment window open here. You can also go up to Services and Deployment. All right, with the module selected, click Deploy Selected, and now we're good to test. Playing the game now, I'm signed in and have a hello message from the Say Hello example function. I'll try Jim instead of Jim Jam. And then we get the warning message from the client validation. Next, let's pretend we're hacking the code on our device. So we'll bypass the client validation. And while I'm here, I'll add a warning log in the catch to represent the message we might give to the player. Okay, so I'll try less than 4 characters. We get a script error and our warning message. Now I'll put in a bunch of special characters, and we also can't do that. You can see the exception error message we wrote in the console too, by the way. It's right here. Argument exception message name is not valid. Now let's do something that should pass the server validation. I'll do Jimbo, and that passes. Of course, we aren't actually saving the name because when we restart the game, it goes back to whatever is in player name. Now we want to save player data, and we want to do this in Cloud Code after the data has passed our server-side validation. Our task then is figuring out how to integrate Cloud Code with Unity gaming services like CloudSave. Integrate with other Unity services is the section on this in the Cloud Code documentation. Here the docs explain that there's a Game API client class that's a simplified interface for calling Unity gaming services like CloudSave, Economy, or Friends from our Cloud Code modules. To use the Game API client interface, we need to register the Game API client as a singleton with this module config class here, and below we have an example of saving and loading data. Copy the module config class, and rather than put it with everything else in our example script, I'll right-click on the project in the Solution Explorer, and then go to Add, and then Class, and let's call the class Module Config. And then paste in the example code. I'm going to switch to my fresh run through here, right-click on iCloud Code Setup, Quick Actions and Refactorings, and using Unity Services Cloud Code Core, and Game API Client will be using Unity Services Cloud Code APIs. And then our last one, right-click on Add Singleton, and select Quick Actions and Refactorings, because we need to add the Microsoft Extensions Dependency Injection namespace. So with this, we're registering the Game API client as a shared resource that any part of our cloud code can use. The new class uses our project name as the namespace. Let's go to the example script and change that. So delete hello world, and let's make this be our project name. And let's also rename this example script. In GemHunter, we use service as a suffix for our cloud code class names. This is just a simple way to make the class and file names distinct from the client-side class names in our Unity project. So this file and class name can be changed to player data service. To rename the file, right-click on the class name, quick actions and refactorings, and rename file to player data service. And there in our Solution Explorer, we can see that the file name is changed. Go back to the documentation page we were just at, and let's copy those save and get data functions. And let's also get the iLogger and constructor at the top in addition to the save and get data methods. Then you can paste that at the top of player data service. And first things first, let's replace the example class name with our player data service class name. Let's skip the logging for now and work with the save and load methods. I'm going to change the formatting to be more readable. While I'm doing this, make note that SaveData uses Game API client cloud save data set item async, and GetData uses get items async. Also check out how the iExecution context provides information like the player ID, the project ID, and authentication tokens. Context is how cloud code knows who and what project is calling it, and that's important for security and data management. Next, let's remove the cloud code function attribute and for now make these methods private. We don't want the client to call these functions because that would allow a hacker to save or get any data they wanted. Getting or reading data is safe, but writing data is where we want to be really careful. Imagine a bank allowing anyone to call and say they have any amount that they want to have. The endpoints should be designed for specific purposes, and our cloud code function handle new player name entry is a good example of this. Let's replace the to-do comment with a call to the SaveData method. We'll need to make several important changes to our function, so let's look at them all and walk through it. Because SaveData is an asynchronous task, we must use the await keyword when calling it, and that requires us to mark our function with async and change the return type to task of string because we're still returning the player's name. SaveData requires specific parameters. The execution context, again for the player ID, project ID, and access token, the Game API client, and then we also need a key to identify our data in storage. At the class level up top, add a public constant string variable named k for constant underscore player name key with the value player underscore name using uppercase because it's a common convention for constant key values. We're passing the key and the new name parameter as the value that should be stored. Before we test this, I do want to note that there is player name support through the authentication service. Here's the documentation on that. Usernames are just a simple piece of player data for us to explore dual validation with. That is the client-side and server-side validation that we're doing with the same isPlayerName valid logic. Head back to Unity and let's generate bindings from services, cloud code, generate bindings. And now you get an error. That's because we renamed our cloud code class from myModule to player data service. So go to your player data manager script and rename the bindings to player data service bindings. All right, so we'll need to rename it here at the top and then when we create an instance. And for now, I'll just rename this to bindings and I'll make it private. And then let's deploy the module. Start the game, and assuming you have something typed for player name, click Save Player Name. And great, there's a successful log, saved new player name in the cloud. Let's make note of the player ID. Mine is J1GV. Let's confirm that the player name is saved by going to the cloud dashboard, clicking on Cloud Save, then Player Data. I have one player here, and they are in fact J1GV. Then we can see the player data that we saved. Awesome. Here above, we discover that there are actually 3 access classes for player data: default, which is readable and writable by the player; public data, which is the same, but it's readable by any other player. So the player name possibly fits this one. Then last is protected, which is only readable by the player. The player can't write or modify this data. In the next video, we'll cover loading player data and the economy. From here, let's check out analytics. In addition to saving the player's data, we also want to collect data that gives us insights about the players and our game. So on the left, click on the plus, select Analytics, and then it'll take a little time to initialize. Go back to Unity, to the Package Manager, and this time click on the cloud icon on the left where there's just packages related to Unity services. Find Analytics and click Install. And while we're here, good idea to install the samples. All right, now let's take a quick look at the Getting Started with Analytics documentation. We set up the dashboard, installed the package, and then here we have the initialization line we need after Unity services initialize async and confirming player consent, which we can skip for now. This is just our learning project. We need to call this line analytics service.instance.start data collection. Back in the editor, okay, let's think about this. We're initializing Unity services in the login manager we created previously, so now's a good time to create a dedicated script for initialization. Right-click in your project folder, create a new script, and call it Game Initializer. All right, then let's open the script and delete start and update. Let's use awake and paste the analytics initialization. Then let's go over to the login manager and take the Unity services initialization and paste it into the game initializer. After we paste this, we'll need to mark awake as async since initialize async is a task. That's all we need to do in the game initializer. However, moving the initialization means we'll have a race condition issue in the login manager, and trying to subscribe to playeraccountservice.instance.signedin when Unity services is not yet initialized. The async task can take some time. So let's move this subscription to a new method, Unity sign-in subscription. And then let's do a check if the services are initialized. In that case, right away, we can subscribe to the player account service event. Otherwise, the subscription will have to wait until the initialized event fires. You probably won't use Unity player accounts, but this change we're making is still important to understand in order to avoid timing or race condition issues. So let's generalize it. Anytime you're subscribing to Unity service events, especially in Awake or early on during startup, check whether services have initialized. If so, you can just subscribe to the event. But if services haven't initialized yet, use the Unity services.initialize event to handle subscriptions once the initialization is complete. And of course, we'll need to unsubscribe to this in onDisable, which we should change to onDestroy since we're subscribing in onAwake. Note that we're unsubscribing from both events here for simplicity, even though we might not have subscribed to Unity services initialized. This is safe in C#, but in production, you might want to track your subscriptions with a flag. Go back to Unity and play the game because that was all we needed to do to get some analytics data. So after you've done that, go to the dashboard in Analytics, and you won't see anything yet. So this is a good time to get lunch or take a break. It'll take a couple hours, but when you come back, you'll see some data like I have here. Excellent. So that is a little bit on Cloud Code, Cloud Save, and Analytics. In the next video, we'll add the economy, and we'll circle back around to add some more to what we started with here.